Network designers use firewalls to protect networks from unauthorized use. A firewall filters unauthorized or potentially dangerous packets from entering the network. Administrators use ACLs to stop traffic or permit only specified traffic on their networks based on information found in the package header. In addition to either permitting or denying traffic, ACLs can be used for selecting types of traffic to be analyzed, forwarded, or processed in other ways. By default, the router does not have ACLs configured. Therefore, a router does not filter traffic by default. Package filtering controls access to a network by analyzing the incoming and outgoing packages and passing or dropping them based on given criteria. A package arrives at the package filtering router. The router extracts certain information from the packet header. Using this information, the router makes decisions based on configured filter rules as to whether the package can pass through or be discarded. An ACL is a sequential list of permits or denied statements, known as access control entries or ACES. ACES are also commonly called ACL statements. Inbound ACLs are best used to filter package when the network attached to any inbound interface is the only source of the package needed to be examined. On the other hand, for the outbound ACLs, the incoming packets are routed to the outbound interface, and then they are processed through the outbound ACL package needed to be examined. Outbound ACLs are best used when the same filter will be applied to package coming from multiple inbound interfaces before exiting the same outbound interface. Standard ACLs can be used to permit or deny traffic only from source IPv4 addresses. The destination of the package and the ports involved are not evaluated. Extended ACLs filter IPv4 package based on protocol type, source IPv4 addresses, destination IPv4 addresses, source TCP or UDP ports, and optional protocol type information for finer control. Standard and extended ACLs can be created using either a number or a name to identify the ACL and its list of statements. Number ACLs numbers from 200 to 1299 are skipped because those numbers are used by other protocols. The figures summarize the rules to follow to designate number ACLs and name ACLs. IPv4 access control entries include the use of wildcard mask. Wildcard mask is a string of 32 binary digits used by the router to determine which byte of the address to examine it for a match. Subnet mask use binary ones and zeros to identify the network, subnet, and host portion of an IP addresses. Wildcard mask use binaries 1 and zeros to filter individual IP addresses or groups of IP addresses to permit or deny access to resources. Wildcard mask bit 0 match the corresponding bit value in the addresses. Wildcard mask bit 1 ignore the corresponding bit value in the addresses. Here's an example. Calculating wildcard mask can be challenging. One shortcut method is to subtract the subnet mask from 255, 255, 255, 255. The keywords host and any help identify the most common uses of wildcard masking. These words eliminate entering wildcard mask when identifying a specific host or an entry network. The host keyword substitutes for the 0000 mask. This mask stays that all IPv4 address bits must match or only one host is matched. The Any option substitutes for the IP addresses and 255, 255, 255, 255 mask. This mask says to ignore the entire IPv4 address or to access any address. An extended ACL can filter traffic based on the source address. However, an extended ACL can also filter traffic based on the destination address, protocol, and port number. This prevents unwanted traffic from being sent across multiple networks only to be denied when it reaches its destination. Locate extended ACLs as close as possible to the source of the traffic to be filtered. This way, undesirable traffic is denied close to the source network without crossing the network infrastructure. A standard ACL can only filter traffic based on a source address. This allows the traffic to reach all other networks except the network where the package will be filtered, because standard ACLs do not specify destination address. Place them as close to the destination as possible. Placing a standard ACL at the source of the traffic will effectively prevent that traffic from reaching any other networks through the interface where the ACL was applied. When traffic enters a router, the traffic is compared to all ACEs in the order that the entries occur in the ACL. The router continues to process the ACEs until it finds a match. The router will process the package based on the first match found, and no other ACEs will be examined. ACEs are processed sequentially. Therefore, the order in which ACEs are entered is important. If no matches are found when the router reaches the end of the list, the traffic is denied. This is because, by default, there is an implied denied at the end of all ACLs for traffic that was not matched to a configured entry. A single entry ACL without only one denied entry has the effect of denying all traffic. At least one permit ACE must be configured in an ACL or all traffic will be blocked. To use number standard ACLs on a Cisco router, you must first create the standard ACL and then activate the ACL on an interface. The command access list at global configuration defines an ACL with a number in the range 1 to 99 or 13,000 to 1999. This allows a maximum of 798 possible ACLs. This is what you must do to delete an access list. The remark keyword is used for documentation and makes access list a great deal easier to understand. Each remark is limited to 100 characters. You can use the remark keyword to include comments about entries in any IP standard or extended ACL. The remarks makes the ACL easier for you to understand. The IP access group command specifies the ACL should be applied to packets as they enter into the interface using the command in, or apply it to packets as they exit the interface using the command out. Naming an ACL makes it easier to understand its function. At global configuration mode, use the IP access list command to create a named ACL. ACL names are alphanumeric, case-sensitive, and must be unique. The IP access list standard plus the name is used to create a standard named ACL. The command IP access list extended plus the name is for creating an extended access list. There are two ways that a standard numbered ACL can be edited. For an existing ACL, you can use the show running config command to display the ACL. Copy and paste it into a text editor, make the necessary changes, delete the previous ACL, and then paste it back in the new corrected order. Or you can display the current ACL using the show access list 1 command. Enter the IP access list standard command. This command is used to configure named ACLs. Delete the misconfigured statement and add a new sequence numbers. There's an example. The show IP interface command is used to verify the ACL on the interface. The output from this command includes the number or name of the access list and the direction in which the ACL was applied. The figure shows the result of issuing the show access list command. To view an individual access list, you should use the show access list command followed by the access list number or name you want to see. Once the ACL has been applied to an interface and some testing has occurred, the show access list command will show statistics for each statement that has been matched. During testing of an ACL, the counters can be cleared using the clear access list counters command. You can control which administrative workstation or network manages your router with an ACL and an access class statement configured on your VDY lines. The access class command configured in line configuration mode restricts incoming and outgoing connections between a particular VDY into a Cisco device and the addresses in an access list. Here's an example. Extended ACLs are used more often than standard ACLs because they provide a greater degree of control. Extended ACLs check source addresses of package, but they also check the destination address, protocols, and port number or services. This provides a greater range of criteria on which to base the ACL. The ability to filter on protocol and port number allows network administrators to build very specific extended ACLs. An application can be specified by configuring either the port number or the name of a well-known port. Local operations can be used, such as equal, EQ, not equal, NEQ, greater than, GT, and less than, LT.
Continuing, configuring an extended IP version for ACLs, and this will create the ability to filter on protocol and port number, allows network administrators to build very specific extended ACLs. An application can be specified by configuring either the port or the name of a well-known port. Extended ACLs are used more often than standard ACLs because they provide a greater degree of control. As shown in the figure, like standard ACLs, extended ACLs check sources addresses of packets, but they also check the destination address, protocols, and port numbers or services. This provides a greater range of criteria on which the base of the ACL. For example, an extended ACL can simultaneously allow email traffic from a network to a specific destination while denying files transfers and web browsing. These are some commands, an example of applying an ACL to an interface. As you can see, the command access list and the extended ACL that we set, it is greater than 100, and then the command permit TCP and the address with its card. This will establish the access list with the list of addresses you can permit or establish. After that, you can use the command interface and the interface you want to configure, and also create the access group with the number you established, or in or out configuration. These are the steps for creating a name extended ACL. First, from a global configuration mode, use the IP access list extended name command to define a name for the extended ACL. In the example, you can see that like surfing, or in the second part, browsing. These are the names of the ACLs. In the step 2, I name ACL configuration mode, specify the condition to permit or deny the access. For step 3, return to privilege mode, exit mode, and verify the ACL with the show access list name command. This will show you all the configuration for the ACLs and the list of them. For the last step, save the entries in the configuration file with the copy running config startup config, the command that you already know, to save the configuration of the startup config. Processing packets with ACLs. Standard ACLs only examine the source AP version 4 address. The destination of the packet and the ports involved are not considered. The destination process for a standard ACL is mapped in the figure. Cisco iOS software test addresses against the condition the ACL one by one. The first match determines whether the software accepts or rejects the address. Because the software stops testing conditions after the first match, the order of the condition is critical. If no condition match, the address is rejected. For IP version 6 ACLs, these ACLs are very similar to the IP version 4 ACLs in both operation and configuration. Being familiar with IP version 4 access list makes IP version 6 ACLs easy to understand and configure. In IP version 4, there are two types of ACLs, standard and extended. Both types of ACLs can be either number of name ACLs. In IP version 6, ACLs are name ACLs only, and other characteristic is that equivalent to the functionality of IP version 4, that it is equivalent to the functionality of the IP version 4 extended ACL. Some differences between IP version 6 and IP version 4. Applying an IP version 6 ACL, the first difference in the command used to apply IP version 6 ACLs to an interface. IP version 4 uses the command IP access group to apply IP version 4 ACL to an IP version 4 interface. IP version 6, on the other hand, uses the IP version 6 traffic filter command to perform the same function for IP version 6 interfaces. And this in the next continuing with the presentation, you will see some examples to know some of these commands. Also, no wildcard marks. Unlike IP version 4 ACLs, IP version 6 ACLs do not use wildcard marks. Instead, the prefix length is used to indicate how much of the IP version 6 source or destination address will be matched. Additional default statements. The last major difference has to with the addition of two implicit permit statements at the end of each IP version 6 access list. At the end of every IP version 4 standard or standard ACL, it is an explicit deny or deny any command. IP version 6 includes a similar deny IP version 6 any statement at the end of each IP version 6 ACLs. In this sample, you can see how to configure the IP version 6 ACL. For the first step, like I said, the global configuration mode uses the IP version 6 access list name command to create an IP version 6 ACL, like IP version 4 name ACLs. IP version 6 names are alphanumeric, case sensitive, and must be unique. Unlike IP version 4, there is no need for an standard or extended option. In the option, you can see this like no are router free LAN access. This is the name of the access list of the ACL, and the deny and the permit command for the direction in version 6 IP. For step 2, from the name ACL configuration mode, use the permit or deny statements to specify one or more conditions to determine if a package is forward or drop. For the last step, return the privilege mode except mode with the end command. As you can see, it's really easy to configure at ACL IP version 6. You only have to create the access list, put the IP you want to deny or permit in any case, and finish the configuration with the end command. IP version 6 ACL configured to an interface. As IP version 4, it's really easy to configure in an interface. You only have to use the command IP version 6 traffic filter the name of the named ACL you have created before, and put the command in to let that interface to be an access port. These are at last some examples you can use, where you can see all the commands we have been shown of the configuration for the ACLs in IP version 6. In the first example, you can see the deny command, the TCP, and the direction you want to deny, and the command of permit IP version 6 any for any other destination IP address you want to permit it to establish the access. And also, it is in the example you can see a configuration for an interface in gigabyte server 0, and with this simple command that I said, IP version 6 traffic filter node FTP to 11. This is the name. Only you can put any other name of your ACL you have configured in the upper part, and the command in to apply an access mode for this interface. There is a bigger example in the right part, and where you can put a bigger access list where you can permit or deny any other destination. There is also use the remark command that will permit if the telnet access can be accessed from the PC free to any other PC or between any other interface. And this is for all, and thank you for watching this video. Goodbye.